Section: Abstract. We're excited to introduce H2O-Danube-1.8B, a language model with 1.8 billion parameters that we've trained on 1 trillion tokens. This model is built on the foundational ideas from Llama 2 and Mistral, and we've fine-tuned various techniques to train large language models more efficiently. Even though we used fewer tokens for training compared to other similar-sized models, H2O-Danube-1.8B performs exceptionally well across a wide range of benchmarks. We've also developed a chat model version, which has been further improved through supervised fine-tuning and direct preference optimization. We're making H2O-Danube-1.8B freely available under the Apache 2.0 license, aiming to make large language models more accessible to a broader audience without a heavy financial burden. In recent years, research has significantly advanced the capabilities of language models, making them crucial for various tasks like generating text and code, answering questions, translating languages, summarizing content, and more. The most advanced large language models today often use a decoder attention architecture, which has been shown to benefit from pre-training on large text datasets. It's understood that the performance of these models improves with larger sizes, more data, and greater computational power for training. This has led to the creation of many models of varying sizes to optimize performance based on available data and computational resources. Despite the trend towards larger models, smaller models have also become important, as they can efficiently run on consumer hardware and are faster for specific tasks. This concept has been proven by the success of BERT and its derivatives. In our work, we build on this research and introduce H2O-Danube-1.8B, a large language model with open access. It adopts key principles from Llama 2 and Mistral and is trained on a diverse dataset excluding coding data. Despite using fewer tokens for training, it competes well across various benchmarks. We also offer a chat model variant, H2O-Danube-1.8B Chat, which has been enhanced with supervised fine-tuning and preference data optimization. For the model architecture, we've adjusted the Llama 2 architecture to fit around 1.8 billion parameters, with a hidden size of 2,560, an intermediate size of 6,912, and a total of 24 hidden layers. We use the original Llama 2 tokenizer with a vocabulary size of 32,000 and train our model to handle up to a context length of 16,384 tokens. We've incorporated several key features in our model architecture. 1. Sliding window approach for local attention. We use a fixed sliding window of 4,096 tokens for training, which helps in managing the model's attention to local information within a text. 2. Rotary Positional Embedding, ROPE. This technique helps the model understand the position of different elements in a sequence, improving its ability to handle various types of input. 3. Grouped Query Attention. To reduce memory usage, we've designed our model to use 32 attention heads and 8 key value heads, which helps in processing information more efficiently. 4. Root Mean Square Layer Normalization, RMS norm. We use this technique for both pre- and post-normalization to ensure stable training. We've also chosen not to use bias in linear layers or tie-word embeddings. For training, we used a single node with 8 H100 GPUs, employing Distributed Data Parallel, DDP, so each GPU holds a full copy of the model. We experimented with smaller data and model sizes to find the best training settings and hyperparameters. We trained the model on sequences of increasing length, starting from 2,048 tokens to 16,384 tokens, using a total of 700 billion tokens. We also utilized 8-bit floating point calculations to speed up training, with certain layers in FP8 precision and the LM_head layer in B-float16 precision to maintain stability. We used the AtomW optimizer with specific settings for beta values and a cosine learning rate scheduler, starting with a warm-up phase and then decaying the learning rate. Our training achieved an average throughput of 292.7 thousand tokens per second on a single node. Section Summary. We introduce H2O-Danube-1.8B, a 1.8B language model trained on 1T tokens, following principles from Llama 2 and Mistral. Despite being trained on fewer tokens compared to similar models, it demonstrates competitive performance across various benchmarks and is openly available under the Apache 2.0 license, making large language models more accessible. Additionally, we release a chat model trained with supervised fine-tuning and direct preference optimization, further extending the model's utility. Section: Results. We tested our model, H2O-Danube-1.8B, against a variety of benchmarks to see how it stacks up against other open-source language models of a similar size. These models include Tiny Llama, which has 1.1 billion parameters, Falcon and OPT, each with 1.3 billion parameters, Cerebra's GPT and Pythia deduped, which have parameters ranging from 1.3 billion to 2.8 billion, Qwen with 1.8 billion parameters, and the most recent Stable LM2 with 1.6 billion parameters. Most of these models are available under the Apache 2.0 license, but Stable LM2 and Qwen have extra requirements for commercial use. To compare these models, we used the Language Model Evaluation Harness framework, specifically the version used in the OpenLLM leaderboard. We looked at how the models performed in different areas: common sense reasoning, world knowledge, reading comprehension, and overall performance on the OpenLLM leaderboard benchmarks. For common sense reasoning, we checked how the models did without any prior examples, zero-shot setting, on 6 standard benchmarks. For world knowledge, we looked at how they performed with 5 examples, 5-shot performance, on the Trivia QA benchmark. For reading comprehension, we again looked at zero-shot performance, this time on the Bool Q benchmark. The OpenLLM leaderboard tests models on 6 key benchmarks in both zero-shot and few-shot settings, covering a wide range of reasoning and general knowledge. Our model, H2O-Danube-1.8B, performed well across all these areas compared to other models of similar size. It was particularly competitive with the Qwen and Stable LM2 models. It outperformed Qwen in all areas except Bool Q, even though Qwen was trained on more than twice the number of tokens. However, it was slightly behind Stable LM2 in most areas, even though Stable LM2 was trained on 4 times more tokens for 2 epochs. It's worth noting that both Qwen and Stable LM2 have extra requirements for commercial use, unlike most models which are available under the Apache 2.0 license. In the OpenLLM leaderboard, H2O-Danube-1.8B, along with Qwen and Stable LM2, were the top performers. They had comparable results on most benchmarks, except for MMLU and GSM-8K. This could be because Qwen and Stable LM2 were trained on data specifically tailored to improve performance on certain benchmarks. For example, Qwen used a dataset designed for better math reasoning. We also created a chat fine-tuned version of H2O-Danube-1.8B, called H2O-Danube-1.8B Chat, which is available under the Apache 2.0 license. We used H2O-LLM Studio, a no-code GUI and open-source framework, for fine-tuning language models. We started with supervised fine-tuning on conversational input-output pairs from various datasets, totaling 157,000 samples. We trained the model for 1 epoch with a learning rate of 0.00001, a batch size of 8, and used cosine learning rate scheduling with a short warm-up period. We kept the full pre-trained context length, masked the prompt loss, and used a custom prompt format, optimizing hyperparameters through multiple experiments. Section Summary. The H2O-Danube-1.8B language model was evaluated across various benchmarks and compared to other models with similar parameters, showing strong performance in common sense reasoning, world knowledge, and reading comprehension tasks. It outperformed most competitors, except for Stable LM2, and also has a chat fine-tuned version released under Apache 2.0 license. Additionally, the model underwent supervised fine-tuning using conversational datasets, achieving good results across different benchmarks. Section: DPO. We use a method called supervised fine-tuning, specifically through direct preference optimization, DPO, by combining different datasets that together have about 17,000 samples. These datasets include ultra-feedback binarized, ORCA DPO pairs, and distillable math preference DPO. We train the DPO model using a technique called LoRa, setting specific parameters such as the rank to 4, alpha to 16, for one training cycle. We use a small batch size of 2, a learning rate of 0.00001 with a gradual decrease in the learning rate over time, and set beta to 0.2 for the DPO loss calculation. Then, we do another round of fine-tuning with the OSIS2 dataset, creating pairs based on English conversations, with about 5,000 samples. This time, we use a slightly lower learning rate of 0.000003. When it comes to evaluating our chat model, which has been fine-tuned for conversations and instructions, we face a big challenge. The most reliable way to test it is by having a lot of people use it and give feedback. For a preliminary test, we use MT-Bench, which has a variety of multi-turn questions. We exclude coding questions since they're not relevant for our model, H2O-Danube-1.8B. We adjust the model settings to reduce randomness and make the comparison fairer. Our model shows strong performance, especially in natural language tasks, and is the best in 5 out of 7 categories for single-turn conversations. It performs comparably to other models in the second turn of conversations. We've made the weights of both the intermediate and final DPO models available online for others to use and improve. We're planning to make further improvements, especially by using more complex conversation data for training. We also encourage the open source community to adapt our models for different purposes. Additionally, we evaluate our chat models on various benchmarks, including common sense reasoning, world knowledge, and reading comprehension. Our H2O-Danube-1.8B chat model and another model called STABLELM2 Zephyr perform better than 2 other models, QuenChat and Tiny Llama Chat, on most benchmarks. The only exceptions are the MMLU and GSM-8K benchmarks, where our model doesn't do as well, possibly because the other models were trained with specially selected data to excel in those specific benchmarks.